Section 4.3, Laws of Logarithms. So there's three main laws that we'll be talking about. First one, log base a of a times b can be split up to be log base a of a plus log base a of b. That just means that multiplying can be split to addition. Similarly, division can be split to subtraction, or you could think about it the other way. Addition can be combined to multiplication, subtraction combined to division, as long as the bases are all the same. And also, log base a of something to a power, the power can get moved in front. So multiplication and addition go together, division and subtraction go together, powers can get moved to the front. So let's take a look at some examples. So first we have log base 2 of 6 times x. We're going to rewrite it. We're going to split it apart. This would be log base 2 of 6. Since it's multiplication, it becomes addition. Log base 2 of x. Log of the square root of 5. Think of square root as a power. That'd be log of 5 to the 1/2 power. And powers can get moved to the front, so 1/2 log 5. Here we have multiplication, so let's split it to addition. So log base 5 of x to the third plus log base 5 of y to the 6th. Then, since we have exponents, exponents move to the front, powers move to the front, so this becomes 3 log base 5 of x plus 6 log base 5 of y. And last, we have natural log of AB over the cube root of C. So first, let's look at the division. So that becomes natural log of AB minus natural log of cube root C. Since it's A times B, that can get split up. Natural log of A plus natural log of B minus natural log, this would be C to the 1/3. And the power can get moved in front, so that becomes natural log of A plus natural log of B minus 1/3 natural log of C. We can also work these types of problems backwards. Condensing, as long as their bases are the same, we can combine them to be 1 log. So this could be log base 4. We'd multiply 2 times 32, which is going to be 64. Two times 32, so that's log base 4 of 64. As long as the bases are the same, base 2, log base 2, since it's subtraction, it becomes division. 80 over 5. So that's log base 2 of 16. And now we have a negative 1/3 in front, which can become a power. So that would become log of 8 to the negative 1/3. And since it's a negative power, that would become 1/8 to the 1/3 power. 1/3 power means cube root, so that becomes cube root of 1 is 1, cube root of 8 is 2. So it's log of 1/2. Now we can actually go one step further, because log base 4 of 64 can actually be solved out. That's a number. 4 to what power equals 64? So that would be 3. Because 4 to the 3rd is 64. 2 to what power is 16? So 2 to the 3rd is 8. 2 to the 4th is 16. Since 2 to the 4th is 16, this would just be 4. And this doesn't get a... You could estimate it using a calculator, but if you just type log 0.5 or log of 1/2, you would get negative 0.301. Now we're going to take more complicated logs and just combine them. So we're going to work these backwards, kind of, and numbers in front become powers. So this would become log x to the 3rd plus log of x plus 1 to the 1/2, which is really just saying square root. And then since it's addition, you can combine that to multiplication. Since it's the same base, they're both just the common log. So that becomes log x to the 3rd times the square root of x plus 1. We can do a similar thing with this example. Numbers in front become powers. So this becomes natural log of s cubed plus natural log of t to the 1/2, so square root of t, minus natural log of t squared plus 1 to the 4th. Since this is addition, it becomes multiplication, since they're all in the same natural log. So it's natural log of s to the 3rd times the square root of t, and minus means over, t squared plus 1 to the 4th. And then the last rule that we're going to look at is the change of base. If you have log base b of x, that's the same as taking a different base. Normally you would do this with the common log or natural log. But you can do log of x over log of b of any base that you want. X goes on top, the base goes to the bottom. So you could rewrite log base 8 of 5 as log of any base we want of 5 over log of 8. Now the reason that that's useful is because on your calculators there's only a log button and a natural log button. So if we write this as common logs like we did, you can do log of 5 over log of 8. which works out to be 0.774. You could do the same sort of thing with natural log, like I said. So this one, we could do the change of base formula and write it as natural log of 20 over natural log of 9. Or you could do the common log, it doesn't matter. Natural log of 20 over natural log of 9. So you get 1.363. Now, most calculators only have natural log and log. If you have the newest version of the TI-84, there's actually a way to do log base anything you want. To get to that, it's in the Math menu. So you go to Math, and then scroll down or up as a shortcut, all the way down to option A, log base. And then it allows you to put in both. So we can put in the 8 and the 5 for our first example here. And you see we get the same answer. Same thing for example B. We can go back to log base. Put our base of 9 and the 20, 1.363. But not every calculator has this function. If yours is updated, then you might have this. And if you wanted to graph a function, a log function, you could do it either way. You could do as a change of base, just type that into your y equals when you're graphing it on your calculator, or you could do the log base in your y equals as well. Either way.